Hello dear kiddos, how are you? This is Varsha and welcome to PW Gulf. Today we are going to finish the topic Basic Mathematics of class 11th. Are you guys ready for it? What are the things that I am planning to cover today? Today I'll be covering these three topics, which is hit and trial method. Hit and trial method, very important. Next, logarithms, very important. And the third one, wavy curve method, again a very important topic, guys. All these three things which you will be studying in today's class is going to help you a lot, no matter whether you are in class 11th or class 12th. Do watch this video start till end. I have taken lots of questions. Generally we have summary sessions. In summary sessions we go through the pointers, the theory part, but here it's basic math, so let's learn it from the basic. Are you guys ready for it? The very first thing, very interesting, hit and trial method. What is this hit and trial method? Why are we using hit and trial method? We all know how to factorize a quadratic equation. We all know how to factorize a quadratic equation, like let's say x square plus 4x plus 4. We all know how to factorize it. Factorize it, x square plus 4x plus 4. You can write it into two parts like this. Easy, ma'am, we know it. This is called factorization. But what if I give you a cubic equation or a biquadratic equation? Biquadratic meaning the power is 4. The highest power will be 4. If I give you a cubic equation, something randomly, x cube plus 3x square plus 9x plus 9, and I ask you what will be the factors. Of course, it's a cubic equation, so it should have 3 factors. Quadratic will have 2 factors, cubic will have 3 factors, and biquadratic will have 4 factors. So what are these 3 factors? There's one method which you have already studied, few of you would be knowing, the polynomial division method. What you usually do, you write this x cube plus 3x, okay, let me write it here, x cube plus 3x square plus 9x plus 9, and when you are asked to divide it with some number, let's say x plus 1, you divide x cube by x, then write here x square into x cube, x square into, I hope you must be knowing this method. But this is a very typical approach and we do not have that much time to keep on dividing. Also, what if this is not given to you? Also, if this is not given to you, I just want these 3 factors. What will you do in such a case? So there is a shortcut for it, and that is called as hit and trial method. Understand very carefully. I'll be taking 4 examples for hit and trial method. In that 4 examples you should be able to understand what is the hit and trial method. Guys, generally we take values like 1, minus 1, 0, 2, minus 2, half and minus half. These are the values which we generally check, which we generally hit. Example, here is a first cubic equation. Can you say it's cubic? X cube plus 2x square plus x minus 4. Right. We want to find the factors of it. What are the factors? That is, simplify this cubic equation. First step everyone, listen carefully. You will be writing all the coefficients of the cubic equation. The coefficient of x cube is 1. The coefficient of x square is 2. The coefficient of x raised to 1 is 1, and the coefficient of x raised to 0. Here nothing means x raised to 0. Higher to lower power 3, 2, 1, 0. Higher to lower power all the coefficients. This is minus 4. So first step is writing down all the coefficients. All coefficients, and it's important that you write in decreasing order. That means if any of the term is missing, you will put a 0 in that place. I'll take an example of that situation also. For now, I've written down all the coefficients. Next, you will take any number and hit. What numbers will you take? I have given the sequence. Try with 1, -1, etc., etc. Hit numbers like 1, -1, 0, 2, -2, half, -half. These generally within these numbers you will get the answer. So let's hit with 1 first. I'm trying whether 1 is a factor or not, whether 1 will give me the answer or not. What is the step? First step, whatever number is there, carry it downwards. As it is, 1 is written down. Then cross 1 into 1. So like this you will cross, up and down you will add. Up and down, add. In cross you will multiply. 5. So this 1 into 1, 1 is written here. 1 ones are 1, written here. And up and down, add. 2 plus 1, 3, written here. Cross 1 into 3, 1 into 3 is 3, written here. Up and down, add. 1 plus 3, 4, wrote here. Cross 1 into 4, 4, wrote here. Up and down, add. -4 plus 4, 0, hooray! Once you get 0, that's the answer. Final number should be 0. Final number should be 0. If you get 0, this is a correct hit. If final number is 0, it is a correct hit. What if it's not 0? Instead of 0, you get 3, 2, any other number, -9. Then you will change the hit. You will, instead of 1, you will try -1 or 0 or 2, -2. You will change this hit number. Are you getting it? So you will take randomly any number, solve this by method of hit and trial, also called synthetic division. If you get 0, good luck, it was a right hit. And now listen carefully what you will do. This number 1 should be written like this with a minus sign. Whatever number is there, you will write it here in a minus sign. And these 3 terms are the coefficients of quadratic equation. 1 into x square plus 3 into x plus 4. Very easy, guys. Go slowly. You can slow the speed. You can try to understand. It's absolutely easy. Once you understand, matter of few seconds. X minus 1, x square plus 3x plus 4. Now, this is quadratic. Do we know to factorize it further? Yes. X minus 1, x square plus 3x plus 4 can be, can we factorize? 4 ones are 4, but then minus sign, we can't. We can't. So, but anyways, this will have 2 roots. It's quadratic. You can solve it by b square minus 4ac, the formula method. Minus 3 plus or minus root of b square minus 4 4s are 16 upon 2a. The only thing is both the roots will be imaginary. Both the roots will be imaginary. Imaginary roots, imaginary factors. So we are right now dealing with only real numbers, and that's the reason we will not factorize it further. We can, dealing with complex number you can, but for now this cubic equation has been simplified. Can you see the cubic equation has been simplified? Couldn't understand? No worries. Remember this 4 step. I'm trying one more question. First you will write all the coefficients in decreasing order. Then you will hit with any of the numbers. Then up and down, add, cross, multiply. Like 1 cross 1 ones are 1. 2 plus 1 3, cross 1 3s are 3. 1 plus 3 4, cross 1 into 4 4. Minus 4 plus 4 0. Bingo. This is another question. Let's try to factorize it. Guys, first step, writing down all the coefficients. 1, minus 6, 11, minus 6, right? Cube, square, 1 and 0, all in decreasing order. What number should we hit? Our usual. Let's try with 1. Maybe we can get the answer. I'm trying with 1. That's my hit. This 1, there is nothing over here, which means 1 plus 0. That 1 comes down. Cross 1 into 1, 1. Minus 6 plus 1, minus 5. Cross 1 into minus 5, minus 5. Add 11 minus 5, 6. Cross 1 into 6, 6. Minus 6 plus 6, 0. Bingo! We are getting answers with 1. That may not be the case every time, but yes, now it is. Why not utilize it? Next, this one should be written in a bracket like this. And these three terms will form a quadratic equation. X square minus 5x plus 6. Well, this can be factorized, isn't it? This can be factorized. X minus 1. Should it be 2 3s are 2 minus 2 minus 3 or 6 1s are? Minus 2 minus 3 minus 5 minus 2 minus 3 plus 6 and 6 1s are. Right, it should be minus 2 minus 3. The factors are minus 2 minus 3. And this particular cubic equation has been factorized into 3 factors. So this is extremely needed when you solve questions of continuity, differentiability in class 12th, limits in class 11th, okay, and many more. Everywhere, almost everywhere you'll find this cubic equation. You'll have to simplify it, and many of the times numerator gets cancelled with the denominator. All we are doing, synthetic division, hit and trial method. Let's suppose for the same question, 1 minus 6, 11 and minus 6. Instead of 1, I am just trying out with any other number which can be minus 1. Let's try with minus 1 if that gives me the answer. First step, carry this 1 downwards. Second, multiply minus 1 into plus 1 is minus 1. Minus 6 minus 1, minus 7. Multiply minus 1 into minus 7 plus 7. 11 plus 7, 18. Cross, multiply minus 1 into 18, minus 18. And minus 18 minus 6 will be minus 24. Is it 0? No. So is it the required hit? This hit is not correct. So it's like you're randomly shooting, blindly you're shooting in the dark. One of the arrow goes at the right target. Rest of them may not go. So which directions to try? I have already told you. 1 minus 1, 0, 2 minus 2, half and minus half. These are the most preferred directions where if you hit, it will reach the target. In this case, minus 1 doesn't give us 0. That means minus 1 is not a factor. Minus 1 is not the correct factor. In that case, you can try another number. If you try with 2, you will get 0. If you try the same question with 2, 1 minus 6, 11 minus 6. Try it with 2. Why 2 will give me the answer? Because I can see 2 is a factor. From here, 1 is the root, 2 is a root, 3 is a root. So yeah, this 1 carried down, 2 1s are 2, minus 6 plus 2 minus 4, cross 2 minus 4 minus 8, 11 minus 8, 3, 2 into 3, 6, 6 minus 6, 0. Bingo! We get the right hit. Now this should be written as x minus 2 and these three terms as x square minus 4x plus 3. Further, x square minus 4x plus 3 can be factorized. You all know what are the factors? 3. So 3 1s are 3, minus 3 minus 1 minus 4, minus 3 into minus 1 plus 3. I can write the factors as minus 3 and minus 1. Obviously, we get the same answer. That means if you get 0 at the end, answers will remain same. It is factorizable. If you don't get 0, it is not factorizable. Understanding? One more? I think it's now quite clear, but okay, I can hear few students saying, ma'am, please do it. 2, 1 minus 13 and 6. Bring this 2 down as it is. Oh, firstly, what are we hitting it with? Which number shall we try? 1, our favorite, easy. Yeah. To bring this 2 down, then 1 into 2, 2, 1 plus 2, 3, 1 into 3, 3, minus 13 plus 3, minus 10, 1 into minus 10, minus 10, 6 minus 10, minus 4. Boo! Not the correct hit. Try another number. 2, 1, minus 13 and 6. Minus 1 or 2. Let's try with 2. Bringing this 2 as it is down. Cross multiplication. 2 2s are 4. Up and down add. 1 plus 4, 5. Cross multiplication. 2 5s are 10. Up and down add. Minus 13 plus 10 minus 3. Cross multiplication. 2 into minus 3 minus 6. Up and down add. 0. Bingo! We get the answer. That means this is one of the factor, x minus 2. You write it with a minus sign. And these three like this. 2x square plus 5x minus 3. Right? 3 terms, it will form quadratic. 4 terms, it will form cubic. This quadratic can be further factorized, like 2 3s are 6. So what are the factors? This x minus 2, let it be as it is. 2x square 6, right? We need the multiplication as 6. Minus 6 we need. Okay. So 6x minus x minus 3. X minus 2. 2x common. X plus 3 minus common. X plus 3. That's x minus 2. 2x minus 1. And x plus 3. Can you see this particular cubic equation has been factorized into 3 factors? These are called as factors. And if I ask you roots, roots means the values of x. The values of x which will satisfy this cubic. From here x is 2, from here x is 1 by 2, and from here x is minus 3. These are the roots. How do you get the roots? By putting each factor equal to 0. That's how you get roots, isn't it? In quadratic solving also, that's how you get the roots. I hope now this is super duper clear to all of you. One last question for a final trial. X cube plus 2x plus 1, it is a cubic equation. We will follow the same hit and trial method. Guys, this hit and trial method is applicable for quadratic, it's applicable for cubic, it's applicable for biquadratic, and also even higher powers. But only thing is, when you go to higher powers, this particular synthetic division method you will have to apply more than once. In our syllabus, we will try to restrict ourselves to cubic. Right. This is not a proper cubic. Let's rewrite this cubic. X cube plus 0 x square plus 2x plus 1. Now it's perfect to be solved. What are the coefficients? 1, 0, 2, 1. What should we hit it with? 1. Let's try with 1. Bring this 1 as it is down. Cross multiply. 1 1s are 1. 0 plus 1 1. Cross 1 1s are 1. 2 plus 1 3. Cross multiply. 1 3s are 3. 1 plus 3 4. No, it's wrong. Try something else. If you don't get anything by this method, then leave it. Okay, let's try it with what, say minus 1. Our next Brahmastra. Bringing 1 down as it is. 1 into minus 1 minus 1. 0 minus 1 minus 1. Minus 1 into minus 1 plus 1. 2 plus 1 3. Minus 1 into 3 minus 3. 1 minus 3 minus 2. Oopsie, now what? Now what, guys? Now what? Where should we go? What should we do? We are unable to get the answer. It's okay. You know why this question is taken? This question is only taken to tell you that when you divide this cubic equation, x cube plus 2x plus 1, when you divide it, I have taken 1 over here. So when you divide it with x equal to 1, that means x minus 1 equal to 0. When you divide it with x minus 1, the quotient will be 1 1 3. That's x square plus x plus 3. And this, after doing that synthetic division, everything, after solving, the remainder will be 4. If you divide that same x cube plus 2x plus 1, if you divide it with That's x equal to minus 1, x plus 1 equal to 0. If you divide it with x plus 1, what will be the quotient? Quotient is this, x square minus x plus 3, this. And on solving, the final remainder will be minus 2. So many a times you have done it in 9th standard. Divide, polynomial division, you have done polynomial division, dividing one polynomial with the other polynomial, and you had to find the remainder and quotient. You don't have to do that actual division. The remainder and quotient you can get by synthetic division method. By this method you get the quotient and the remainder. When the remainder is 0, in the previous question the remainder was 0. Suppose this is 0, this is 0. When remainder is 0, that means it is factor. It completely divides that polynomial. If remainder is not 0, it is not completely dividing the polynomial. As simple as that. Okay, right. Remainder and this thing quotient. So in a question, when you solve it by synthetic division, this thing is your quotient and this thing becomes the remainder. Remainder 0 means it is completely factorizing. Remainder non-zero means it's not dividing, not able to factorize. That's it. I think the middle portion, this remainder, it's written remainder here, may not be visible white and white. That's okay. You hear it from me. Done with the hit and trial method. Practice more cubic equations. Just pick up any cubic equation and try to factorize it. It will be very helpful, mark my words. Next topic, logarithms. What is logarithm? Why are we studying logarithm in class 11 suddenly? Logarithm is nothing but a tool. It's a tool for easier calculations. It makes our calculations simple, right? Like when I was introduced for the first time with logarithm in my class 11th, I really felt that why is the need of logarithm? I can do that calculation with pen and paper with our old school technique much faster than learning this logarithm, log, anti-log, the properties of log, the rules of log. Like I'm going to now teach you for another half an hour logarithm. So you might wonder that, okay, what is the problem with our old school methods? It's good, right? That's what I thought. But trust me, once you get your hands on logarithms, biggest of the calculations can be simplified, like this. Biggest of calculations. Now I can't even write such a big calculation, but literally if you have 22,9,000, I don't know what is this number, into 36.1213 upon 43.91 cube root the whole raised to 52. I mean, such terrible calculations if you have to do. Your logarithm is going to be very handy. Understanding the log, anti-log, the properties. So spending half an hour or 1 hour on understanding the logarithm is fully worth it, guys. Next, logarithms are of two types, can be divided into two categories. We study two types of log. One is your natural logarithm, the other is common logarithm. What's the difference between natural and common? The difference is natural logarithm will have base equal to e. What is e? E is Euler's number. E is a constant. E is a constant. Till 10th standard we didn't have any such number. Okay. The way you have pi is just a constant, a number. Similarly, e is just a number called as Euler's constant. E-U-L-E-R-S. Euler is a mathematician. Its value is roughly 2.23 something, 2.27 something. For common logarithm, the difference is base is equal to 10. Natural logarithm is written like this, log to the base e. Common logarithm is written like this, log to the base 10. Written at the bottom, at the base, that number is base. Natural logarithm can also be written as ln common logarithm can also be written as just log. If nothing is written at the base, it's by default common logarithm. That means it's understood base system. If just ln is written, it's understood it's a natural log we are talking about. Alright, fine. Where is natural log used? Natural log is used in all calculus. All the calculus that you will be doing in class 11th and 12th. Limits, continuity, differentiation, from there on, everywhere. Derivative of log x 1 by x. You have studied in physics maybe. Derivative of log x 1 by x. That log x is natural log. You might be wondering, ma'am, it's not written e at the base. It's understood, it's taken by default in class 11-12 that the base is e. When we say derivative of log x is 1 by x, that's natural log. Where is common log used? Common log is used for simpler calculations, mostly in calculations and in calculus. Now, calculus and calculations are not same. Okay, yeah. We are not going to address that question for now. Next, when I say log, a log can be represented in two formats. Any number can be represented in two formats. What are the two formats? The first form is, let's call logarithmic form, and the second form is called as exponential form. And be ready to always convert from logarithmic to exponential, exponential to logarithmic will be used multiple times. Logarithmic form. Color, which color do you want? Color, which color do you want? Okay, I don't have much color choices, right? I cannot take blue, shades of blue. I can take red, green, orange, white. White is mixing with this. Okay, logarithmic. Logarithmic. Log n to the base a is equal to, let's say, x. Log n to the base a is equal to x. This number is called as base, your a. This is called as number whose log you are finding, and x is called as index. When you convert this logarithmic form into exponential form, what happens? This log will go away, a pushes x upward, log goes away, a comes on the right and pushes x upward. This is exponential form. These two are interchangeable. Can you see? X is the index, a is the base, and n is the number. Okay, next thing guys, logarithmic form to exponential form. Well, let's see if this color goes well. I write log of 25 to the base 5 is equal to 2. Let's say this is your logarithmic form. Log of 25 to the base 5 is 2. Try reading it with me. Log 25 to the base 5 equal to 2. Log 25 to the base 5 equal to 2. Base, index, number. Index. So it will go up. Index will go up. When log goes away, this 5 comes on the right, pushes 2 upwards, and its exponential form will be 25 is equal to 5 comes here, pushes 2 up. 25 is equal to 5 square. Understanding? Right. There is some property of log. When I say log of n, or they have said log of x, let's take log of any number x to the base a, it's compulsory that this number x should be greater than 0. It's by definition, guys. No questions asked. No questions asked. Why? It is the definition. Log of x to the base a, x should be greater than 0. A should also be greater than 0. Base should always be positive. And also base should not be equal to 1. No questions asked. That means if I say log of minus 2 will be how much? Ma'am, it doesn't exist. Log of negative number doesn't exist. We always talk about log of numbers which are greater than 0, not even equal to 0. Log 0 doesn't exist. Log negative doesn't exist. Log positives, yes, it exists. But again, if I say log of 30 to the base 1 doesn't exist. Base should not be 1. Remember this definition very well. This box you have to remember. Condition for log, definition of log. Right, this is, you have studied relations functions, then y is equal to log x, it's a function. Express 5 cube is equal to 125 in logarithmic form. We studied log to exponential, now exponential to log. When I bring log, this log 125 is equal to, here when I bring log, right hand side 5. This 5 comes to the base and 3 is left here. What happens ultimately? This 5 pushed 3 upwards. So now 5 will come back to the feet. 5 comes to the feet of log and we get this back. Let's try for a few more examples. Guys, in order to understand log, you have to read it this way also. When I say log of n to the base a is equal to x, you have to ask a question to yourself. What question will you ask? When I say log of n to the base a is equal to x, you will ask a raised to what power? A raised to x is n. So a raised to what power will give me n? For example, here 5 cube is equal to 125. When I am expressing it in logarithmic form, or 5 cube is equal to 125, sorry, I am expressing it in logarithmic form. Log of 125 to the base 5 is equal to 3. You have to ask a question, 5 raised to what? 5 raised to what will give me 125? This what is the answer to your log? What is the answer to log? Example, log of 81 to the base 3 will be how much? So you ask a question, 3 raised to what will give me 81? 3 raised to what will give me 81? 3 raised to 4 will give us 81. So answer to log is that what? That 4. Let's write log of 64 to the base root 2 will be what? We'll ask the question, root 2 raised to what will give me the answer as 64? Root 2 raised to what? Let's say that what is x? Root 2 raised to x is 64. Now 64 is 2 raised to 6. 2 raised to x by 2 is equal to 2 raised to 6. Right? The power root goes off. X by 2 is equal to 6. X is equal to 12. So here the answer is 12. Let's take more examples. I know you are getting interested now. Okay, log of 144 to the base 12 will be how much? Very simple, ma'am. 12 square is 144. So just take the answer as 2. Okay, ma'am, done. What is this? Log of root 9 to the base 3 will be how much? 3 raised to what power will give me root 9? Now root 9 is nothing but 3. That means log 3 to the base 3. 3 raised to what power will give me 3? 3 raised to 1 will give me 3. So the answer is 1. Okay. So similar way, lot of questions can be created. For now, I can go ahead and deal with some properties of log. These properties you can just keep on noting. Again, it's a property helpful for simpler calculations. Log 1 is always 0, guys. Beat any base. Any base, when I say within the definition, base should not be 1, base should be greater than 0. Suppose log 1 to the base 31, 0. Log 1 to the base 22 by 4, 0. Log 1 to the base minus 2, not defined. Why? Because base cannot be negative, it should be greater. If it is negative, then it is not defined. Agreed? So log 1 always 0, that's the general way of saying log 1 0, log 1 0. Log a to the base a is 1. When you have number and base same, within the limits, within the definitions. Log 3 to the base 3, 1, we just saw. Log of 225 to the base 225 will be 1, because 225 raised to what is 225? 1. A raised to what is A? A raised to 1 is A. So always if you have same numbers, the answer is 1. Property 3, the product law. It is the product law of log. The product law, when you apply, make sure that the bases are same. Addition of log converts into multiplication provided the bases are same. Log 3 plus log 9 will be equal to log of 27. Yes. Why? Because bases are same. Ma'am, bases are not mentioned. Not mentioned means it's 10. By default, it's 10. Log 2 plus log 6 to the base 2 to the base 3. Will it be equal to log of 12? No, it cannot be, because the bases are different. The bases are different. 3 and 2 different bases, we cannot apply product law. Okay? We don't know what the base here will be. So, only applicable when bases are same. Addition of log converts into multiplication. Here, this is the quotient law. That is division of log. Log x1 minus log x2 is equal to log of x1 by x2. Again, the bases should be same everywhere. Property 5, exponential rule. Product, quotient, exponential. What does exponential rule says? The power will come here. Suppose you have log of 3 square is equal to some x. According to the exponential law, this 2 can come here. That means 2 times log 3 is equal to x. This 2 simply comes here. What mistake happens? Let me rectify that. Suppose you have log of 3 the whole square is equal to x. Now your students are very smart. They're like, okay, exponential, let's go with exponential. 2 will come here. 2 times log 3 is equal to x. Is it correct? It's not correct. When it's the whole power of log, you cannot apply exponential. It's only applicable when the power is on the number. When the power is to 3. When the power is on the number 3 or whatever is that number, A, you can bring the power outside. Remember this property. Based on that property, here is a question. Solve for x if log of x minus 1, log of x plus 1 is log of 1 to the base 2. Okay. Solve. We have to solve. Log A plus log B. On the left hand side, can I apply product law? Log A plus log B as log of A into B. Bases are same, right? Nothing means 10. No bases, same bases. That's equal to log of x minus 1 into x plus 1 is equal to RHS log 1 to the base 2. RHS I am not touching. LHS only I have touched. What have I done? Product law. Next, a minus b, a plus b is a square minus b square is equal to log 1 to the base 2. Right? Next, this base 2 is something misleading. Yeah, log 1 is always what? 0. We know that log 1 to any base, you take any base, the answer will be 0. 0. Here, what is the base? If nothing means 10, 10 goes up. Logarithmic to exponential conversion people, log will go away, 10 pushes 0 upwards. Log to exponential conversion, log goes away. I do not want log to exponential. Log goes away, this 10 pushes 0 upwards, 10 raised to 0. X square minus 1, anything raised to 0 is 1. X square is equal to 1 plus 1, 2. X is equal to plus or minus root 2. Well, is it the answer? Is that the value of x? No. No, that is not the final answer, my boys and girls, my kiddos. If I take x is equal to minus root 2, what happens in the question? The value of root 2 is roughly 1.414. Right? Remember, the value of root 2 is roughly 1.414. So if you substitute x as 1.414 here, minus 1.414 minus root 2, what will happen to the log? Minus root 2 minus 1. It's a negative number which doesn't exist. Log of negative number doesn't exist. So can I take x as minus root 2? No. X minus root 2, not allowed. What about x equal to plus root 2? Yes, root 2 minus 1. It's positive. Root 2 is 1.414, more than 1. Root 2 plus 1, positive. Log of positive numbers exist. So I will take x as plus root 2. The answer to this question is x is equal to plus root 2, not minus root 2. Noted? Very, very good. Property 6. You thought the properties are over? No. Log b to the base a is log b upon log a. This property's name is change of base law. Why change of base law? When suppose you want to change the base. You don't like this base a. We don't like this base a. We need a new base. When you want a new base, separate them, put a new base c. Log of 32 to the base 3. I don't like this 3. Okay, fine. 32 log 3. Now put any base of your choice that you like. I like 2. Done. Okay. Next. Seventh property, a raised to log x to the base a is equal to x. When this number, these two bases are same. 3 raised to log 90 to the base 3. These two numbers are same. The answer will be 90. These two numbers are same. Answer will be 90. Important property, guys. Many of the students forget by the time they reach class 12 because generally we use exponential, product and quotient. These three are used very frequently. After that, change of base law. So this property is less used. We tend to forget. Another important property, a raised to log b is same as b raised to log a. Suppose you have 2 raised to log 9. You can also write it as 9 raised to log 2. Interchange. Very much possible. Nothing wrong. Alright, now let's go for the questions of log. I have lots of questions on logarithm and we are going to solve it. Ready, steady, go. Solve this. 5 raised to log x to the base 10 plus x raised to log 5 to the base 10 equal to 50. Solve means find the value of x, always. People, just the 8th property. 5 raised to log x to the base 10 is fine. Can I interchange this x and 5? X raised to log 5 can be written as 5 raised to log x. Aha. Yes. Which property? A raised to log b is same as b raised to log a. Now this is 2 times 5 raised to log x to the base 10 equal to 50. Divide this 2 on the right hand side. 5 raised to log x to the base 10 is equal to 50 upon 2, 25. 25 can be written as 5 square. So on left and right, bases are same, 5 and 5. I can compare the powers. Log x to the base 10 is equal to 2. Now logarithmic to exponential conversion will give me the answer. Always when you want to find x, 90% of the times you have to remove the log, because without removing log, how will you get x? You want x to be separated. So you have to say bye-bye to log. And to say bye-bye to log, you should know exponential conversion. So this 10 will come here, push 2 up. X will be equal to 100. That's it. Done, done. Understood? Understood, my dear boys and girls. Lovely, lovely. So this reasons I may not be writing. I hope it will be okay. Listen carefully while solving. And this reasons writing is unnecessarily taking a lot of time. Oh my god, a very nice important question. Log to the base 4 of cube root of 8 raised to 3 plus 1 by 3 log x to the base 2 is equal to 4. Solve and get the value of x. Alrighty. Firstly, I am going to convert this log to exponential because I have a problem with this log. Because of the log, I am not able to simplify anything. So if I convert this log to exponential, 4 will come here, push 4 upwards. We will have 8 raised to 3 plus 1 by 3 times log of x to the base 2, the whole raised to 1 by 3, equal to this 4 coming here and pushing it up. Well, this cube root is also a problem, so let's cube on both these sides. Four raised to 4, the whole raised to 3. 8 can be written as 2 cube. You must be wondering, why ma'am, why are you doing this? Just check, just have a little patience. This is 4 raised to 4 3s are 12. What have I done? 8 is written as 2 cube. And now this 3 can be multiplied. It's like a raised to m, the whole raised to n is a raised to m. So this 3 will get multiplied with the entire power. Isn't it? Oh yeah. So 2 raised to 3 multiplied with the outer 3, we get 9. 3 multiplied with the second term, 3 by 3, gone away. Log x to the base 2 is equal to 4 raised to 12. Now 4 is nothing but 2 square. 2 square raised to 12. Why am I doing that? Because here the base is 2, there the base should be 2. That's the simple reason. 2 raised to 9 plus log x to the base 2 is equal to 2 raised to 12 2s are 24. Can you see bases are same? Chew. If bases are same, powers can be equated. 9 plus log x to the base 2 is equal to 24. 9 on the other side. Log x to the base 2 is 24 minus 9, 15. Log to exponential. Finally, we need x. Log has to go. Tata bye bye to log. X is equal to 2 raised to 15. That's the answer. Done. Okay. I deleted one of the properties, a raised to m. This is law of indices, simple. Getting it? Lovely. Next. Find the value of this. Oh my god. Try this. You can pause the video, try this question using all the properties that you have studied. Let me do it for you. Okay, I'll rewrite the question just in case you find it a little cluttered. It's 1 upon 2 raised to log of 2008 to the base 0.5. Alright. Numerator is 1, so I might also write it like this. 1 upon 2, the whole raised to log of 2008, and 0.5 is nothing but 1 by 2. Can you recall the property number 7? A raised to log b to the base a is b. If this number is same, if the bases are same, we get directly the answer. 2008. Which property? A raised to log b to the base a is equal to b. I said the property which many students forget. Base is same, number direct. Half, number direct. Because of 1, we take full advantage of that 1. Next question. Prove this LHS is equal to 1. Whenever it's a proof question, LHS taken separately, RHS matched with it. It's x raised to log y by z. That can be written as log y minus log z into, dot is into, y raised to log z minus log x. Guys, I am using the quotient rule. What is quotient rule? Log of a by b is log a minus log b. So instead here z by x, log z minus log x into z raised to log x minus log y. Further, the property of indices, a raised to m minus n is nothing but a raised to m upon a raised to n. Oh yes. X raised to log y upon x raised to log z into y raised to log z upon y raised to log x into z raised to log x upon z raised to log y. Well. One more very nice property. A raised to log b is same as b raised to log a. Interchange A and B. A raised to log B is same as B raised to log A. So x raised to log y, isn't it same as y raised to log x? And y raised to log z, isn't it same as z raised to log y? Just yz interchanged. Also x raised to log z and z raised to log x, everything cancels. That's 1, which is RHS, hence proved. Understood? Nice. Enjoying? Learning? Great. Superb. Log of 1 by 8 to the base x is minus 3 by 4. What is the value of x? A, B, C, D. Now this is like a quiz. You all have to answer yourself. Enough of solving, isn't it? Now quizzy. Let's play the quizzy. Guys, one more portion is left. If you want, take a rest, have some water, and I am doing it non-stop in one take. I don't take pauses. I am not drinking any water as yet. So one more portion, very important part, wavy curve method is left and extremely important. So do not skip the video. Save it, watch later. If you cannot do it in one go, it's fine. Make notes. Write all these questions, solve all these questions in your book. Just convert this logarithmic to exponential. 1 by 8 is equal to x raised to minus 3 by 4. Okay. 1 by 8 can be written as 1 by 2 the whole cube is equal to x raised to minus 3 by 4. 1 by 2 can be written as 2 raised to minus 1 the whole raised to 3 is equal to x raised to minus 3 by 4. That's 2 raised to minus 3 is equal to x raised to minus 3 by 4. Yeah. Now, from the power minus 3 can get cancelled from both sides, or if you take cube roots on both sides, minus 3 will get cancelled. 2 is equal to x raised to 1 by 4. Just take to the power 4 on both the sides. So 2 raised to 4 is equal to x raised to 1 by 4 the whole raised to 4. I am raising both sides to power 4. 2 raised to 4, 16, 4 cancel, x is 16. D is the answer for this question. Find the value of log x minus 10 to the base 10 equal to 1. Which is the best color? I am still unable to understand. White maybe, okay. Again logarithmic to exponential. This 10 will come here, push 1 upwards. On the left side you have x minus 10 is equal to 10 raised to 1. X is equal to 10 plus 10, 20. Answer is option A. The red one, the one marked in red is the answer. Solve for x. Log 225 upon log 15 is equal to log x. What is the value of x? Okay, log 225 can be written as 15 square upon log 15 is equal to log x. Okay. Using the exponential rule, exponential property after a very long time, this 2 will come over here. The power of 15 will come and sit besides log. Log 15 cuts, log x is equal to 2. But we need the value of x, not log x. Base is 2. Convert logarithmic to exponential. X is 10 pushes 2 upwards. X is 10 square, and that is option number B. B is red. Perfect. Log of a by b plus log of b by a is equal to log of a plus b. Then what is the value of multiple options? On the left side, let's apply the product law. 2 logs when added, I will combine the log and multiply the term inside. A by b into b by a. Isn't it the product law? On the left hand side, I have applied the product law, people. A cancel, b cancel. I will be left with log 1 is equal to log of a plus b. Now what people mistake here is log 1 0, they go for 0, something like that. If 0 was the answer option, you would have marked that, but remove log from both the sides. From both the sides, log is removed. And a plus b is equal to 1. Answer is option A. Guys, you don't have to show that you are cutting the log. No need. It's understood. If you cut, it will go wrong mathematically. It's understood that log from both the sides nullify each other. Nullify is the right word for it. Another question. Looks dangerous. No, it's not. A cube b cube by c cube, b cube c cube by d cube, c cube d cube by a cube minus 3 log b square c is equal to which option? Okay. Log something plus log something plus log something. Let's add all the logs then added can be combined together and terms inside can be multiplied. So a cube b cube by c cube into b cube c cube by d cube into c cube d cube by a cube. Write the product law. Very, very frequent law used. A cube cancels with a cube, c cube cancels with c cube, d cube with d cube. We will be left with log of 2 times b cube. B cube into b cube is b raised to b cube the whole square into c cube minus 3 times log of b square c. People, b cube the whole square into c cube, can I rewrite it like this? Log of b square into c the whole cube. Just check it. Rest everything I am continuing, but this is b square and c and the whole cube. Okay, the exponential law. 3 times log of b square c minus 3 times log of b square c will give me the answer as 0. Difficult the question looks, easier is the answer. The answer is option D, 0. Log of 5x minus 9 minus log of x plus 3 is equal to log 2. Then what is x? Two logs are getting subtracted. My brain says I need to use the quotient law. 5x minus 9 upon x plus 3 is equal to log of 2. Log from both the sides can nullify. 5x minus 9 upon x plus 3 is equal to 2. Cross multiply and you are done. 3x is equal to 15, x is equal to 5. Answer is option B. Perfect. Log of log x is equal to 0, then x is 1. Okay, here you will have to apply the logarithmic to exponential conversion 2 times. Everybody pause and try. 2 times. You will first remove this log, then you will try to remove this log in order to isolate your x. So if I am removing this log, this 10 will go and push this log removed, 10 goes and pushes the 0 up. 10 raised to 0 is nothing but 1. Now I am removing this log, 10 again goes and pushes that 1 up. So x raised to 10, 10 raised to 1 is nothing but 10. C is the answer. Oh, it's never ending kind of. You'll do this. Students are saying that ma'am will complete it now. Like we'll be able to do. 2 divided here. 4 by 2, 2. Log to exponential 2 is equal to x square. X square is equal to 2. So x is equal to plus or minus root 2. X is equal to plus or minus root 2. Okay. Very good. Log 27 to the base 9 minus log 9 to the base 27 is how much? Think. You will get confused a lot. You will try using the property number 7, 8, interchanging 27, 9, but nothing works. It's simple change of base law. Log 27 upon log 9 minus log 9 upon log 27. Okay, now what? All of them, 9 and 27 are powers of 3. 27 can be written as log of 3 raised to 3. 9 is log of 3 square minus log of 3 square log of 3 cube. Use the exponential law. This was right now change of base law. Do you remember the change of base law? Okay. I didn't like the base 9. Separate it. This 3 comes here, 3 times log 3 upon 2 times log 3 minus 2 times log 3 upon 3 times log 3. Log 3 cancels up. We have 3 by 2 minus 2 by 3, and that's equal to 9 minus 4, 5 by 6. C. Gotchas. Nice. One more, log x to the base 2 minus 3 times log x to the base 2 is 6. What is the value of x? Let's put this 3 up first. Log x to the base 2 minus log x cube to the base 2 is equal to 6. Why this cube? Exponential. Can be applied both ways. Next. Log a minus log b is log of a by b. Guys, I'm not writing the reasons. First term divided by second term, right? Base is 2 equal to 6. Log a minus log b is log of a by b. 2 goes there. One of the x's cancels, so it's log of, it's log of 1 upon x square to the base 2 equal to 6. 1 by x square is equal to 2 raised to 6. Simplify. X raised to minus 2 is equal to 2 raised to 6 is how much? 64. And 64 is 8 square. Yeah, it is 8 square, but 1 by 8 square. I need minus 2 in the power. I need minus 2. So we'll write 1 by 8 raised to minus 2. Do you agree? 1 by 8 raised to minus 2 is nothing but 8 square, which is 64. And x can be equated to 1 by 8. Option D. Or if in case you are unable to understand, just check. This is 1 by x square is equal to 64. That's 1 by x square. 64 means 8 square. Rearrange. X square is equal to 1 by 8 square. X is equal to plus minus 1 by 8. Actually it should be. But we will not take minus, because minus will give me log negative. If I take x as negative, it will give negative log, and that's not allowed. In the previous question there was minus root 2. But that was base. And can the base be minus negative? The base cannot be negative. So answer should be 2. See, we figured out a problem in the question. X should be only root 2. Reason? This base, by the definition, log of x to the base a, whenever you have a should be greater than 0, not equal to 1. How can I take this base? Negative, we can't take. So there was an issue. If any of you pointed before me, well done. Do not accept everything blindly. Do not accept everything blindly. There can be mistakes, okay? Alright. So many questions, no? Last one. Log of a the whole raised to b is equal to what? This is a mistake question. It is log of a the whole raised to b only. Do not confuse it with option A. It's not exponential law, cannot be applied. We cannot apply exponential law, people. Why? Because the power is not to b, but it is to the whole log. Fair enough. Next, number system, just saying, because there might be few confusions, and basic mathematics tells me that it's my right to tell you about the number system, although we have studied it in sets. The smallest of all, do not mind the diagram, we just are focusing on the understanding part. Natural numbers, that is 1, 2, 3, 4. Then whole numbers 0, 1, 2, 3, 4, 5, 6 and so on. Then integers, all the positive numbers, negative numbers as well as 0. Integers represented by z. Then rational numbers. Now rational numbers will have all the decimals, fractions also. Positive numbers, negative numbers, 0. But now there will be 1 by 2, 1 by 3, 1 by, all these fractions, everything will be there in rational. But there is something called as irrational also, which is not rational. Like something which is in the form of p by q is rational. Irrational, your pi, root 2, all these are irrational numbers. E. So irrational number is a completely different set, this is a different set, and all of them combined will form a real number set. So real number set has a big set rational numbers and another set irrational numbers. All of them combined real numbers, capital R. And yes, next chapter that you will be studying very soon, all these numbers, real numbers, rational, irrational, everything comes under the complex numbers. Complex numbers have real numbers also a part of it. So that's the biggest set. Please remember, don't get confused with the name how you denote it. Representation on number line, union, intersection. I hope these two things, basics, should be clear before we go to wavy curve method. Wavy curve method, why we will use, I'll tell you. Union, intersection. Union is or, the keyword for union is or, for intersection is and. Open and closed interval, let's recap once again in case. Dot is used when you have closed intervals, okay, that is when you have slack inequality. When you have slack inequality. What is slack inequality? Slack inequality, that means when you have less than equal to, greater than equal to, then in that case dot is used. Bubble. Bubble is used in case of open interval. Open interval, that means strict inequality. It's not included. Less than or greater than. There is no equal to sign, you will go with those symbols. Dot, bubble on a number line. On a number line. Okay. Fine. So if you have a question like this and you have to represent it on a number line, assuming x belongs to real number, how will you do? 3x minus 3 goes on the other side as 5. X is less than equal to 5 by 3. Right? This is your x. On a number line, you will take the number 5 by 3. Less than equal to 5 by 3, guys. This time less than as well as equal to. Equal to means dot. And less means on the left. Less means left, greater means right. X is less than 5 by 3. Less means on the left minus infinity, on the right plus infinity. Final answer, x belongs to minus infinity to 5 by 3. Minus and plus infinities will always have open interval. Minus and plus infinities will always have round brackets, open intervals, because you cannot include infinity. Any number cannot be equal to infinity. No equal to, that's why round. But 5 by 3, is it included? Yes, there is a dot. Dot means, remember the right hand side, dot. Dot was closed. That's how you represent on a number line and in sets interval notation. X is greater than equal to 0. If you simply have to put this on a number line, greater means on the right side, equal also, that means dot. Greater than equal to 0. How will you write it on a number line? 0 to infinity. Infinity always have open. 0 has a dot. Dot means square bracket, closed interval. This intersection has to be represented on a number line. X is greater than equal to 2 intersected with x less than equal to 5. A number line, minus infinity plus infinity to 5. First part says x is greater than equal to 2. Greater and equal, like this. Less and equal to 5. Less means on the left. Now whenever, guys, there is intersection, please remember, whenever there is intersection, I should write it here itself. Whenever there is intersection, what will you do? You will check for parallel lines only. Parallel lines only. And whenever there is union, you will go for all the lines. All the lines present. What does this mean? What am I trying to tell you by this? Here we are finding the intersection. Alright. Let me take a better way to show you. Plus infinity, minus infinity, 2 and 5. The first one says x is greater than equal to 2, equal also on the right side. Second says less than equal to 5, equal also and left also. What will be the intersection portion, guys? Intersection portion means where the lines are parallel. Where are the red lines parallel? In which area do you see red lines parallel? In this area. In this area red lines are parallel. Here there is only one red line. Here there is only one red line. Here they are parallel. So answer will be the parallel area. Always remember, intersection means parallel area. So 2 to 5 is the answer. 2 and 5 both are dot. 2 and 5 both are included in the answer. And means intersection. Okay. Minus infinity plus infinity. There is 0 and there is 2. X is greater than 2, not equal to, just greater. When there is equal to, dot. No equal to, bubble. X is less than 0, left. Okay. We need intersection. Which is the area where two lines are parallel? Where are the two lines parallel? Is there any area? No, I cannot see. This is alone, this is alone. That means no common area. X is phi, null, no intersection area. There is no intersection area. One more. 2, 6, 4. Okay. On a number line, minus infinity plus infinity. 2, 6, 2, 4, 6. Not 2, 4, 6. Let's draw. First, x is greater than 2. Just greater than 2, guys. Do not mind this small differences. Greater than 2, not equal to. Then x is less than 6. Okay, right? And third one, x is greater than 4. Greater means on the right. Greater on the right, less on the left. Now, where is the area where you find all three red lines parallel? All this area has only two red lines. This has two red lines. This area has all three red lines. So the common area intersection of all three is 4 to 6. Are 4 and 6 included? No. Bubble, bubble. Bubble, bubble. Open, open. Not included. Strict. And last one, our lovely union. Our lovely, simple, sweet union. 2, 5. 2, 5. Red line, red line. X is less than equal to 2. Okay, less means this area. X is greater than 5, just greater. So dot bubble. See, remember. Practice and it will be like very easy. Now union means I said everywhere, wherever your line goes. You don't have to look for parallel. In intersection we look for parallel. In union, wherever your line goes. So my red line is here, that's the answer. My red line is here, that is the answer. Final answer, minus infinity to 2. 2 included, minus infinity open. Union, 5 to infinity. Both should be open. 5 is bubble, so open. 2 is dot, so closed. Remember. Will you remember, everyone? If you will remember, I can go to now last topic, which is wavy curve method. Wavy curve method. What is wavy curve method? It is generally the favorite of all the students. Students just love it because it's easy. It solves the questions so easily. With the basics, with the interval notations and everything known to you, wavy curve method is going to make your life very easy. Although it's not there in CBSE, but we will focus here on competitive examinations, and with that perspective, this is going to be very useful for you. And in class 12, there is a chapter application of derivatives, which, trust me, is based on wavy curve method. So yes. And also in class 11th, why to go so far in 12th? In class 11th, you have a chapter relations and functions, and in functions, while finding the range, when you are finding the range, when you are finding the domain, Don't you need this? When you're finding the domain, when you have inequality, when you say anything inside the root, suppose, should be greater than equal to 0. Anything which is inside the root, you say, if inside the root you have this, and you say anything inside the root should be greater than equal to 0. This is your function. You want to find the domain. Domain, okay. If you have referred my sessions of relations and functions, then this is type 3. And in type 3, whenever there is root, we consider that thing should be greater than equal to 0. Now, how do I solve it? What is x? How do I simplify it? To solve such type of questions, wavy curve is absolutely needed. So, yeah, first thing, wavy curve, everyone please understand. Whenever you have x minus a, x minus or x minus plus anything, greater than equal to 0, less than equal to 0, just greater than 0, just less than 0, and not just multiplication I am talking about. Suppose you have few terms in division also. All this format, less than equal to 0, greater than equal to 0, less than 0, greater. All these type of questions where you have to find out what is x can be very easily solved using wavy curve method. What are the steps for wavy curve method, guys? Note these steps. The first step is, now this is very important here. This is very important. Please smile and listen. First step, check x is linear. That means if in a question you have quadratic, cubic, factorize it, make it linear. I'll be writing some extra hints here and there. So factorize and make it linear. Second step, check that coefficient of x in all the factors is positive. That means you always have x plus 3 and you never have something like 3 minus x. If it is negative, if the coefficient of x, here you can see x is negative, what should be done? Make it positive. If the coefficient is negative, you pull out the minus sign and try to make x positive. Second step. These are the preliminary conditions. These are more like conditions instead of steps. You have to check these steps, conditions before solving the question. Done? Next. Third. Put all factors equal to 0 and mark corresponding value of x on real line. Suppose you have factors x plus 3 into x plus 2. What will you do? You will put each factor equal to 0 and x is minus 3. Put another factor equal to 0, x is minus 2. And then put both these factors on a number line, minus 2 and 3. Got it? That's your third step. I will take an example to solve this. Do not worry at all. If something is not visible here, don't worry. I'm saying try to listen. These two factors, put each factor equal to 0 and you will get the value of x as minus 3 and minus 2. Minus 3? Okay, so minus 3 is smaller, isn't it? Minus 3, minus 2. Putting each term equal to 0 and getting the value of x. I will like to call this as critical point, guys, CP. Critical point. It's a term referred lot of times in class 12th also. CP, critical point. When you put each factor equal to 0, you will get CP, critical point. When you put each factor equal to 0, this minus 3, minus 2, these are critical points. Critical means important points. Fourth, put plus sign on extreme right and then change the sign alternatively. So that means there is a number line, right? Infinity minus infinity. There is minus 3, minus 2. You will put plus sign on extreme right, this is extreme right, and change alternatively. That means now plus will become minus, minus will become plus. There are 3 areas. So in each of the area, you will keep on changing the sign alternatively, but always remember last extreme right should be positive. Last step, now mark the intervals and corresponding values of x according to the question. Now suppose if in the question it was greater than equal to 0. Suppose this was the question. You want to find x such that it is greater than equal to 0. Greater than equal to 0 means positive. You will mark your positive regions. This is positive, and the third region, this is positive. There was equal to sign also, so I have put dot. Dot means equal to. That's your answer. Final answer is minus infinity to minus 3 union minus 2 to plus infinity. Okay, got it everyone? No, you didn't get it. Very good. That's what I wanted. You just have to write these 5 steps and now try it out in the questions that I'm telling you. First and second are conditions. You have to see that x is linear, x is positive. Third says find the critical points. Put each term 0 and get x and put it on a number line. Fourth says start with plus, minus, keep on going. I'll share a next level of this also. You'll have to wait for it for some time now. A little complicated one. Fifth step says select your region. If they have asked you positive, select positive. If they have asked you negative, go for negative regions. So here is the first simple question. Guys, it should be done within 5 seconds. X is linear, yes, power 1. X is positive, yes. What are the critical points? This is what I mean by critical point. x1 and x2. These are my critical points. It's our, you and me, our language. On a number line, put this 1 and 2. Fourth step, from right start with plus, keep on changing. Plus, minus, plus. And select the region less than 0, guys. Less than 0, not equal to 0, just less than 0. This is your less than 0. Negative region 1 to 2, closed interval. Question solved. 5 steps done. 5 steps are done. Do you realize? Bingo. Next, x minus 1 into x plus 2 into 3x minus 5 less than 0. Again, you have to solve. Put each term equal to 0, will get 1, minus 2 and 5 by 3. Guys, shortcut yaar. This is not in CBSE. You don't have to write the steps. Come on. Smallest number 5 by 1 will come and then 5 by 3. 5 by 3 is bigger than 1, right? Yes. Start with plus, minus, plus, minus. What do we want? Minus, less than 0, man. Less than 0, negative region, minus infinity to minus 2 and 1 to 5 by 3. Oh yes, great, super. Division, what we were doing for multiplication, is it same for division? It is similar for division. Go for it. Again less than 0. Why always less than 0? I need a change. I need it. Okay, this term critical point 1, this term critical point 2, this term critical point minus 1. So it's minus 1, 1, 2. Plus, minus, plus, minus. See how simple it is, no? Less than 0, minus region. Just select your minus regions and mark it. Minus infinity to minus 1 and 1 to 2. Why am I using open intervals everywhere? Because it's bubble. Why bubble? Because there is no equal to it. Strict inequality. Super. Not so super. Why always the question? What we study in the lecture and what we get in the test. Why there's so much of difference? Like what I taught you questions and what is this? Why? Nothing to worry, guys. Just for a twist in the tail. Numerator 2x minus 1 upon, they have said this is positive. Positive means greater than 0. Will it be equal to 0? Non-negative means equal to 0. I hope you understand this. When I say non-negative, it means greater than equal to 0. It cannot be negative, everything except negative. So 0 is neither negative nor positive. So non-negative means greater than equal to 0. When they say positive, it means simply greater than 0. Remember. From the denominator, if I take x common, 2x square plus 3x plus 1. Do not go for that cubic, whatever you studied today at the beginning, hit and trial. No need. You can take x common. and then simplified. 2x minus 1 upon x. What is this, guys? Simplify, no. 2x square plus 3x plus 1. We need 2 ones are 2. Okay. 2x, x plus 1 plus x plus 1. That is 2x plus 1 and x plus 1 greater than 0. My dear boys and girls, what are the critical points? From here, 1 by 2. Each term should be put equal to 0. So this x also should go equal to 0. This x also 0. From here, minus 1 by 2 and from here, minus 1. Can you see? By putting each of them, this is also a term, man. Fine. Number line. Minus infinity plus infinity. Smallest of all will be minus 1, minus half, 0 and then plus half. Alternate plus, minus, plus, minus, plus. Which region? Greater than 0. Greater than 0, positive region. Answer will lie here, or it will lie here, or it will lie here. Okay. Option doesn't match. Who has asked you to match the option? No one asked you. They said S is the set of all real numbers such that this is positive. S will contain what? This is your S. This is S. This is S. This is S. This is S. So this S will contain which areas? Will it contain minus infinity to minus 3 by 2? Where will be minus 3 by 2? Here. Minus 3 by 2 to 1 by 4. Where will be 1 by 4? Here. And minus 1 by 4 will be here. And then half is here and 3 will be here. Chalo, check. Is the first area within our set? Minus infinity to minus 3 by 2, is it a part of S? Yes. Minus 3 by 2 to 1 by 4, minus 3 by 2 to, is everything between them a part of S? No. This area is not a part of S. Minus 1 by 4 to 1 by 2, minus 1 by 4 to, is everything between them a part of S set? No. This area is not. And last one, half to 3. Where is half? Half to 3 a part of S set? Yes. So answer is A and D. Which of them are a part of solution set? Option A and option D are part of solution set. Check. Perfect. So what we did, we ensured that x is positive everywhere, x coefficient a positive, 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 positive. We ensured that x is linear. Here x was not linear, cubic, quadratic. Make it linear, x raised to 1, 1, 1. We made it linear. After you make it linear, get the critical points. This 1, 2, 3, 4 critical points. People generally forget this 0, so it's important. Mark them, plus minus and get the answer. Awesome. Next one. 2x minus 1 upon x is greater than equal to 1. One pro tip. Make sure your RHS is always 0. RHS always has a 0. Doesn't have any 1, 3, any other number. If there is a number, bring it on the left. Simplify. 2x minus 1. Cross multiply. 2x minus x is x minus 1 upon x greater than equal to 0. Guys, what will be the critical point? Put numerator equal to 0, x will be 1. Put denominator equal to 0, x will be 0. So the two critical points are 1 and 0. 0 first, then 1. Infinity minus infinity. Plus minus plus. We need greater than equal to 0. So all the positive regions should be marked. Guys, do not get confused that greater means right hand side only. No. All the plus areas have been marked. Okay. There's a one small thing to remember in this. One small thing to remember. This. What did I do? Ma'am, you're putting a dot here but a bubble here. Why? It's a common sense. Denominator cannot be 0. Can you make this denominator 0? It's a common sense. If denominator is 0, the function, it will not exist. There is no answer to it. It will blow up. So denominator should not be 0. And what is denominator? X. X should not be 0. So how can I take x to be equal? No, x is not included in the final answer. In the final answer, it's minus infinity to 0, union 1 to infinity. 1 is included, but 0 is not included, open interval. Although this has greater than equal to, this says equal to, include 0, but our common sense says no, x 0, no. This you have to ensure. This is the only difference when it comes to division type of questions. In multiplications you can go directly, but in division type of questions this is the only small thing you have to keep in mind. Denominator not 0 in division. Wavy curve by division, this is the only small thing. Now comes the twist in the tail. What is the twist in the tail, my dear lovely kiddos? The twist in the tail is, not every time you will have this simple nice type of questions where the powers are, you know, where the powers are 1, where the factors are simple, straightforward, where the factors will be 1. No, not every time you will be so lucky. You might get a question like this, the whole cube into x minus line the whole raised to 3000. I mean, what will you do in such a case? We studied for linear. I said x should be linear. But what if it's not linear? I'll tell you, don't worry. I'll tell you how to deal with this type of questions very easily. One simple thing, if the power is even like this, if the power is even, you will continue with the same sign. And if the power is odd, you will change the sign. What does this mean? What does this mean? You'll understand. I'll take a question. Even, same, odd, change. है ना? Just remember a game. Even number, same sign. Odd number, change the sign. Have you all played those games? You stand in a circle, lot of people stand in a circle, and then they say, let's start with a table of 3. Let's start with numbers. Everyone will say numbers, and whenever it's a multiple of 3, you have to clap. Instead of saying the number, you have to clap. Suppose 1, next person, 2, third person. Not saying the number, clap. Then next person, 4, 5, not 6, clap. Then 7, 8, 9, not saying the number, 10, 11, 13, 14, 16, 17. So multiple of 3, you clap. If you don't clap and by mistakenly you say the number 15, you are out of the game. If you have not played it, try playing. Simple and easy and fun, yeah. And people do get caught. So that's what I am saying. Even, same. Odd, change. Right. Here is an example. This 4 is in the power. 1 minus x the whole raised to 4 into x minus 2 the whole raised to 3 is greater than 0. Solve and get the value of x. Everyone, first thing remains the same, yaar. Coefficient of x should be positive. If it's negative, make it positive. Your x is negative. 1 minus x can be written as x minus 1 the whole raised to 4. Power is even, so no problem. Like you know, right? 2 square is same as minus 2 the whole square. If the power is even, it's fine. 2 raised to 4 is same as minus 2 raised to 4. Power is even, it's fine. But if power is odd, can I say 2 cube is same as minus 2 cube? No, they are not. So when power is odd, you cannot interchange the term with it. But when power is even, plus or minus doesn't matter. So I've just written 1 minus x as x minus 1. It's fine. Okay. Guys, similar thing. Find out the critical points. 1, 2. So 1, 2. Infinity minus infinity. Now, from the extreme right, start with plus. This 2 is coming from an odd power, right? 2 is coming from an odd power. So, plus changes to minus. 1 is coming from an even power. When there is an even power, When there is an even power, 1 comes from an even power. 4 is even. Same. Odd means change, even means same. Same sign continues. Minus, continue it to minus only. Do not change minus to plus. Understood? This was your even. This was your odd. So 2 is coming from an odd power, plus change to minus. 1 is coming from an even power, minus remains minus. Final answer is greater than 0. Greater than 0. This is the only region greater than 0. Positive region. 2 to infinity. Done. Question is solved. One more. Interesting. 2123 and here nothing means power is 1. Just figure out the odd and even powers and all the critical points. So here the critical point is 1, from here 2, from here 3 and from here 4. This is odd, this is even, 23 is odd and 4 is even. Right. Are you getting an idea what we are going to do now? Plot all the critical points 1, 2, 3, 4, 1, 2, 3, 4. Now we'll start with plus from the extreme right, plus. But now check, 4 is even. Not 4 is even, but the power of 4 is even. The power of 4 is odd. Who did that? Who did this? The power of 4 is odd. My God. Power of 4 is odd. So 4 power odd plus changes to minus. 3 power odd minus changes to plus. 2. The power of 2 is 100, which is even. So plus remains plus. 1. The power of 1 is 2001 odd plus changes to minus. That's how I decide sign. Now I am not putting blindly plus minus, but instead I am being careful. If when the terms were linear, all the powers were odd, so we were not checking. We were just plus minus, because power was 1 odd. Even 100. The power of 2 is 100 plus continued as plus. Again 1 odd changed. Final answer, we want greater than 0. Now this is an important step. X belongs to 1 to 2 union 2 to 3. Why am I not writing like this 1 to 3 directly? Why not 1 to 3 and 1 to 2, 2 to 3? Because 2 is not included. There is a bubble on 2. It's greater than 0, not equal to 0. There's a bubble. 2 is not in the answer. Everything between 1 and 2 and between 2 and 3 is there. I don't want 2. So I cannot combine the two things. It has to be written separately. Well, in the same question, if there is equal to, same question guys, what you did just now, same, everything same. Minus infinity, plus infinity, 1, 2, 3, 4, plus 4 comes from odd power, minus 3 comes from odd power, plus 2 comes from even power, plus 1 comes from odd power, minus. Greater than equal to 0, this time included. So can I write my x 1 to 3 combined, because 2 is also a part of solution now. 2 is included, so no need of writing 1 to 2 union 2 to 3. I mean, you can also combine this and write 1 to 3, it's fine. Perfect. One more, 2 minus x the whole cube into x minus 21 the whole raised to 6 upon 2x minus 3 the whole square is what? Fine. Can you see x is negative here? Do not forget our initial thing. X is negative, make it positive. The power is odd. So if I bring out the minus sign, x minus 2 the whole cube, right? Minus 2 the whole cube is minus 2 into 2. Minus comes out. X minus 21 the whole raised to 6 upon 2x minus 3 the whole square greater than equal to 0. Guys, what to do with this minus sign? So for those who remember, in inequality, when you multiply with minus sign, on both the sides, this greater than equal to will turn into less than equal to. The greater than equal to sign will change into less than equal to sign. Agreed? When you multiply by a minus sign, or when you divide by a minus sign, this is the rule of inequality. Multiplying and dividing with minus changes the inequality. Now this is ready to go. What are the critical points? Here the critical point is 2. From here it's 21. From here it's 3 by 2. Putting each of them equal to 0. 3 is an odd number, 6 is an even number, and 2 is a even number. Okay, finish it off. Minus infinity, plus infinity. 2, 21 and 3 by 2. 3 by 2, then 2, then 21. Start with plus. 21 power is even, so plus continues as plus. 2 power is odd, plus becomes minus. 3 by 2 power is even, minus continues minus. We want less than equal to 0, guys. The target is here. This is your question now. This is your question. Less than equal to 0. X belongs to minus infinity to 2. Minus infinity to 2. And now, how many of you all understand that in division, the denominator cannot be 0. Denominator cannot be 0. What is denominator? 2x minus 3 cannot be 0. That means x cannot be 3 by 2. In this solution, minus infinity to 2, 3 by 2 is included. You have to remove 3 by 2. So minus infinity to 2 and removing 3 by 2. The single number 3 by 2 is removed from it. That's the final solution, guys. I tried taking all the types of questions of wavy curve. Questions where there is denominator, question there when the RHS is not 0, so you make it 0. Question when the powers are both even, odd. Questions where x coefficient is not positive. You take out the negative sign to make it positive. You made x positive and minus sign changes this inequality. And question where there is denominator, so you take care of the denominator. A lot of variety of questions have been done. That was all for today's amazing session. If you share it with your friends, guys, this is like even after you pay a lot of money, this much of content for free. I mean, so first hit and trial. Do try a lot of questions on that synthetic division. Second, you can take pauses, hit and trial, try questions, relax, understand. Then you go for logarithmic. I mean, we have done so many questions on logarithms. And last, wavy curve. In between, we also saw some basics which I thought was needed, like open close interval number system, unions, intersections, and then we went to wavy curve. Hope you have enjoyed the session thoroughly. Just so that I know you are watching the session, you are liking, please comment, and you can also solve this homework question and comment in the chat box. Comment what is the right answer for this question, a very simple question. That's it for basic mathematics from my side. This is Varsha signing off for today. Thank you so much, kiddos. Bye bye.